Today we're doing a mock interview for Python concept questions.
Hey, hi guys, I'm Gosse. I work as a risk engineer at a bank.
We can talk more about your journey and Python stuff at the end. Let's pull up this Python Iceberg. It's basically 5 layers of Python programming knowledge that goes from like easy to like really advanced. Do you know what sep and end are?
End is essentially the character that will be used as like the end after each line of text. So if you specify end equal to a white space, then this will be printed after the line of text. If you specify end equal to a \n, then it's like a carriage return. And I don't quite know how sep works. I believe it stands for separator.
When you print multiple Python variables, Python would use the sep argument, or like by default is a space to separate among the content on the same line. And then why is print a bad idea in latency sensitive code? I mean, to be like upfront, if you're using Python, you're not writing latency sensitive code. So some of the questions I ask here are more just like important understanding that if you happen to write Python for relatively latency sensitive workload, that you definitely should be aware of and you should expect to be asked in Python interviews. There is actually at least one competitive programming team from like ICPC that uses Python. Most teams will use C++, or Java at least. Yeah, so the question is, why is print a bad idea in latency sensitive code?
So I know that print basically calls the dunder str method under the hood for any object, but I'm not very sure what's the difference or why print is bad.
Yeah, so it might flush the buffer, right? It's similar to like a C++ layout, and then if you do like an underline, then formatting can also like be a latency block in your path. If you want really fast logging, you want like structured logging with levels. And Python has a built-in one, I think. You do, sampling using rim buffers and like make logging really easy in a hot path. Now for the if-else, do you know the difference between equal sign and the keyword is?
The double equals operator, the equal to operator. Yeah, so it's used to compare objects by value, whereas is like an operator which compares them by identity or address. So if there are two aliases or references referring to the same object, like I have a list and L1, and I do an L2 equals L1, and if I were to test if L2 is L1, this would be true because L2 and L1 point to the same list object and have the same ID.
That's pretty good. Do you know in CPython what ID returns by default?
I think it returns the memory address.
Perfect. Really good. Yeah, so in some companies, if the interviewer is really like persistent and annoying, they would actually keep asking you like levels deeper each time until you cannot answer the question.
Yeah.
For the sake of time, I won't do that. I'm going to have to move on. So, and now for loop, do you know what iterable is?
Yes. So an iterable is any collection that implements what Python calls as the iterator protocol. You can think of like lists, tuples, all of these as like iterables. So they are collections of things, and you could just walk through them. And iterator protocol is basically like a contract where you say, okay, I have this container, and my container is going to implement then the iter method and then the next methods. So if you have like your own container, you need to implement these if you want your custom container to be an iterable.
Yeah. And we say that your custom container is not Pythonic if it does not actually support the iterator protocol. Do you know what happens when you call next when the iterable is already at the end?
No, I don't.
Have you used Python for like a long time?
I've used Python a while back, and then I've not used Python for quite a while then.
Gotcha. Anyway, so yeah, what happens is that the iterable would throw a stop iteration exception.
Yeah.
And then for the for loop logic just like catches it by default, so you don't have to worry about it. But if you're doing your own custom iteration logic, like you have to actually catch the stop iteration exception. Yeah. And then here's a very hyper-concentrating flavored question. So what can you do like in lieu of Python loops to speed things up?
Let's say that you want to construct lists and you're working with lists. So I would probably like avoid constructing lists using a for loop and then use like list comprehensions. If you're working with dicts, then and you want a dict, then you'd probably use a dict comprehension.
Nice. So say if you have like a list of numbers and then you know that your workload is a lot of number crunching on these numbers.
Yeah.
Can you think of like a library that you would use for that?
NumPy.
So what technique does NumPy use to speed things up?
Some sort of like vectorization mechanism.
Yeah.
Parallelizes things. Yeah.
That's what's known for. Yeah.
Yeah.
Perfect. Or you can push the hard path to like a more performant or more like low-level language like C++. Using like, for example, the C Python API. That's how a lot of modules are written actually in C or C++, even though you're using it in Python. Yeah, for performance reasons. And then for lists, can you just quickly tell me about the complexities for append operation?
Cool. One, because a list already knows, because for a list, you kind of keep the size of the list is kind of maintained in the list object itself. So when you try to append, it's gonna be big O1 unless there is like a reallocation.
Yeah. Okay. You scared me for a second. When there is reallocation, like what's the complexity?
I think like it allocates like contiguous chunks, and then it has to move some elements over to the next chunk. But I don't know an exact answer here.
I'll give you a hint. Think about C++, which you're more familiar with. Like which data structure in C++ is the most similar to?
Vector.
Yeah. And then what happens when you need to, reallocate for a vector?
Yeah, so you need to move all the elements over.
Right. But basically for Python, I guess what I was looking for is amortized O1. Yeah, they use the word amortized because if you just say O1 like that, might paint like a picture where like, you are not aware of the cost of reallocations.
Understood. Yep.
Yeah, cool. Let's see, functions. How do you take like Variadic arguments?
Yeah, so there's like two ways to do it. So one is positional arguments, and then you can also supply like arguments in the form x equal to y, which are like keyword arguments. Now, if you want to receive a variable number of these positional arguments, then you use like star whatever, star args or star nums. You can name it whatever you like.
Mm-hmm.
It's also called as packing in Python. So it sort of takes that all of those arguments and puts it in args. And then args is like any collection that you can iterate over. With keyword arguments, you can pack those keyword arguments into a dict by using a double star.
Yeah, that's really good. Next one, layer 2. For classes, do you know the difference between class attributes versus instance attributes?
Typically, when you write a class, you could define attributes which are common to all the objects, and there's only just one copy for all the objects. Like all the objects share the same copy of those attributes. So those are class attributes. You typically declare them like above your init or new method. Just declare a variable that becomes a class attribute. I mean, I think you can basically access them by writing the class name dot the attribute name.
Yeah, let's see. Do you know dunder slots?
Every class saves down the list of the attributes that it has in a dict. If you try to access object name dot dunder dict, it's going to give you all the attributes and their values. Mm-hmm. And a more effective way, so you can choose. Python allows you to drop this sort of representation and instead use dunder slots. And if you declare dunder slots, you're packing those attributes in a tuple. It's a more efficient way of storing those attributes here.
Yeah, it's helpful when you have like a large number of small objects in Python. Reduces the memory pressure. Do you know how Python actually manages the memory?
It has like it has a garbage collector, right, which is going to look at all objects which are right now not being referenced.
Mm-hmm.
So even a simple float in Python will have some metadata, and one of the fields in the metadata is obj ref count. And if the obj ref count, I think what Python garbage collector does is it looks at all objects with obj ref count 0.
Mm-hmm. Yeah. So that's reference counting, right?
Yeah.
What about circular references? Because in circular references, every single object has a ref count of at least 1, but there are no external, references to any of the parts of the system.
Yeah.
So how does Python deal with that?
So I don't quite know.
Gotcha. Have you used C# before or Java?
Not really.
Gotcha. So basically, there's a generational garbage like collection stages.
Okay.
Yeah, that's what it's called. But essentially, what it does is that you would periodically scan everything in memory.
Yeah.
And then everything it found to have been to have no external references to it, you would just free all of the parts in that cluster.
Yeah.
And then something that has scanned many times and still alive, you would just move it to the next stage where you would scan less frequently.
I
So
see.
there's a system for it. Yeah, it's pretty interesting. You can also obviously call garbage collection manually to kind of start a garbage collection, and that kind of ties into the guild, which I'll talk about later, because in the next layer. Yeah, and the modules. Yeah, modules. I think they're pretty straightforward. Do you know the definition of module? Like, what is considered a module in Python?
Any .py file is a module, and for each module, Python is going to have a table of symbol names in that module.
Nice, really nice. Do you know the difference between import time and runtime?
Import time is essentially like when you have an import statement, let's say you are importing a module, it's going to scan the module and then bring the symbol that you're trying to import into the caller's symbol table. And obviously it will have to evaluate all of these symbols. So that's done at import time.
Yeah, it's really just like anything that you execute happen. For example, statements outside of any functions, free statements, free variable assignments, those all happen during import time.
Yes.
So if you have a trading process that have some significant startup cost, you want to make sure they're in the import time. So when you start up, you can start up earlier before the trading starts, right? And then all the setup would happen before you actually call the relevant functions. Yeah, otherwise you get a penalty on the first invocation or whatever.
Yes.
And then for dict, how is dict implemented? What data structure is it?
It's a hash table.
Does it use open addressing or separate chaining?
I don't quite know.
Oh, I see. It's actually open addressing.
Okay.
And it uses a combination of linear probe and randomized probing, because it starts with linear probe, so because it's good for cache locality, right? You just fetched whatever bucket from memory, so you can just do a linear probe because it's already in memory. And after a while, if it still doesn't find empty spot, you can just do randomized probing. Yeah, interesting stuff. Cool. Do you know the difference between .get and the bracket operation? The bracket.
If the key doesn't exist, the bracket operation is going to raise a key error, and the .get actually returns a none. You can also supply a default parameter to .get, a default value.
Nice, cool. These comprehensions. Do you know the difference between this comprehension and a generator expression?
A generator expression is just a shorthand way of writing a generator. Whereas a list comprehension essentially you're constructing the list, right? And then you apply some operation to it.
What's a generator? It's in the next layer, but let's talk about it.
Some function that you can pause in between every time, give back control to the caller, and it will remember the state.
Yeah. Now here's a bonus question. Is it possible to reset a generator so it starts from the beginning again? If you make a copy, what happens? Does it keep the same cursor location, or does it start from the beginning? Yeah, well, we can talk about that in the comment section. After the session. Yeah. One sentence definition for each concept in the next layer.
So decorators are wrappers which basically can modify a given function or a class, just used to modify or decorate a class. Next one, context managers are essentially it's essentially a protocol that allows you to do some automatic cleanup or error checking. For example, and you basically use the with keyword when you want to use the context manager. And I actually don't know about metaclasses in Python.
If you have to write your own decorator, how would you do it? That's a very common interview question.
Some decorator, I'd stick in the function name there, func, which will be the function that the decorator would receive. And inside this, I'd write another wrapper function, which is possibly going to have some args and keyword arguments. And then it is going to call func with args and keyword args. It can do anything else that it wants before the function call and after the function call. Finally, the wrapper will return the value, and then the decorator function, which is the outer function, will return the wrapper.
Perfect. The wrapped function, right? Yeah, and then let's see, I think there's one thing that's missing. Have you heard of functools.wraps?
Functools.wraps is, I guess, like basically you're not interested in what the attributes of the wrapper function are, but actually the thing that it wraps.
Yeah, like the metadata, like the docstring, the name attribute. Yeah, nice. That's pretty good. See, context manager. How would you write your own context manager?
I would add dunder enter and dunder exit methods. Let's say I want to open a file, so I'd probably write a class which would have these two methods implemented. And when the with statement executes, the dunder enter method is called, and when the with scope is exited, the dunder exit would be called.
Nice. What happens if there is an exception?
Even if there's an exception, dunder exit would still be called, right?
Yeah. If there's exception in the enter, Python will still make sure to call exit. What happens if the code inside enter calls like return? Like, like at the global level, for example.
I don't know.
It's the same. Exit will still be called. Yeah, Python thought about all of these cases, and they take great care in making sure the behavior is well defined in context.
Gotcha. Yep.
Anyway, next one is Metaclass. So just for the for the sake of education, Metaclass is basically a class of classes. It's a class that can like manipulate or create classes dynamically or programmatically. One common use case is ORM in like databases. Do you know what ORM is?
Not really.
So it's basically object relational mapping. It maps the tables in databases. If you think about SQL, the tables in databases to objects in your actual program languages. So you won't get back, say, like raw data or like a JSON file. You can just like, operate on your query results as if they are like first-class objects in your program language.
Gotcha. Okay.
Yeah. If someone can answer the next layer, the questions on the next layer, I'm pretty confident you can pass the interview.
Okay. All right. So let's go for it. So there are like two different programming paradigms you can think of. So one is like the multi-threaded way of doing things. But my understanding is if you have more idleness in your flow, just to put it simply, more idleness, which means you have more IO bound tasks or network tasks which wait for network packets and so on, then you'd probably like to do it asynchronously. And AsyncIO is essentially like the library which is used to do asynchronous programming. Descriptors, I don't know.
Have you ever heard of use the at property decorator?
At
property. Yeah, that's actually a common interview question.
Yeah, I don't think I've used that one.
Oh, okay. Yeah, and then abstract based classes.
Okay, so just anything which basically represents an interface and can't be instantiated really, and it's going to inherit from the ABC type in Python. And I'll go for GIL. Prior to version 3.14, Python didn't support true parallelism. It only supported concurrency, right? So it used to time slice the tasks. And for this reason, because a thread running on an interpreter can have a data race with another thread running on the same interpreter, and they can basically corrupt the object ref counts. So GIL is a lock at the interpreter level, and that's also like a certain design decision that the Python guys took. They decided not to have locks at an object level, but rather at an interpreter level.
Very good. Yeah. GIL was also asked a lot, and then what you said will definitely impress the interviewers. Yeah. Let's see, AsyncIO. Do you know the difference between cooperative concurrency and the preemptive scheduling?
Yeah, so preemptive is just basically like, the OS scheduler can force a task out of the CPU evict it out of the CPU and schedule whatever it wants to. There's in cooperative multitasking, the task is going to voluntarily yield control.
Descriptor, I'll skip it, but basically it's just objects with get, set, and delete methods. The most common one is the add property one, which is basically a really easy way for you to define getters, setters, and deleters in Python. Yeah, make sure you actually remember add property at least. And then the abstract base class, I think you got it pretty easily. This question is pretty hard. Do you know what Goose Typing is?
Goose Typing.
Yes.
I know
Python
duck
thing.
typing. I don't know if it's the same thing.
No, it's
but
not.
basically it's not. All right.
Yeah. What is duck typing in C++?
Yeah, so it's basically like if an object or a class implements certain behaviors, we say that it is that thing, right? So if
Right. How do you usually do duck typing in C++?
I'm not very sure, but is it like just implementing an interface?
Templates, right? Templates.
Okay.
Yeah. Yeah, in Python, Goose typing is basically subclassing from object-based classes to basically say that you're implementing an interface. And then you can do runtime checking using the abstract-based classes. You can do is instance.
Yeah, is instance. All right.
Yeah. Yeah, it's kind of a fancy way to say like, oh, I will just do your user interfaces in Python. Yeah, actually pretty like simple ideas. But when I first saw Goose typing, I was like, oh, another thing that will really destroy my brain. You even explained why gig exists, which I think most candidates will not be able to answer. So that's really impressive. Python now is able to be gig-free. Yeah, okay, the button layer, bonus stuff. Now we can relax.
Yeah. All right. So, I think that bytecode is essentially like the, let's say, low-level instructions which are generated by the Python interpreter.
Mm-hmm.
Yeah.
Yeah.
When it comes to CPython internals, I think you basically mean like how CPython manages memory, how it stores various kind of objects. So, for example, CPython uses pyvar object it's like basic struct for storing things, and it uses an arena-based memory allocator.
Oh, nice.
I just read some details of CPython, and I downloaded the CPython source code.
Ouroboros is like the snake that can like...
That's a snake that connects to its,
The head of snake can eat into its tail in a circle. Yeah. It's just a meme.
Okay.
Yeah, and the Godot's time is also a meme. It's made by some like dev, joked by some dev, saying that Godot is like able to like foreseeing problems in the future because he has a time machine. He just travels back and points it out in advance in the mail list.
Okay.
Yeah. Yeah. So let's see. So yeah, what's the for the bytecode? Yeah, you're right. It's what the Python interpreter compiles Python into. It's machine independent. So for the same bytecode, compiled bytecode, you can just execute on any platform you want, which is really nice. Do you know how to inspect the Python bytecode?
Not really.
Yeah, you can use the dis module, the built-in dis module, disassembler basically.
Oh, okay. So there's one built into Python itself, is it?
Yeah. It's kind of similar to how like we look at the C++ assembly. Like we want to also check, what it actually does, like stuff like that. Let's see. Do you know what CPython is?
CPython is like one of the implementations of Python runtime or Python interpreter, and there's like there's Jython, there's Pipey. Those are the other ones. CPython is written in C. So
yeah, it's the reference implementation. Yeah.
Okay.
That's everything. Everything in the Iceberg list. I started compiling like my own question bank, basically like starting yesterday. So I'm not fully done yet, but I've got a bunch of really interesting questions that I can talk more in the future. Python is really cool. I guess like one ending question, like now that you know so much about Python, like you know more about an average Python candidate, was really impressive. What does Pythonic mean to you? There's no like correct answer. Yeah.
I think to me it means like following these various protocols in Python. So Also, if you want to write something which takes care of automatic cleanup, use context management protocol. If you want to do something over and over again iteratively, use the iterator protocol. I'd say using these idioms. Similarly, I think that not a lot of, for example, I think that C++ has, when you take any container in C++, you would say, container dot size or len. This in Python, the Pythonic way of doing it is len of the object. So even this is like a Pythonic thing.
Yeah, that's spot on. Yeah, Pythonic is really just following the Python idioms, using the features in Python instead of writing your own for loop when you can just use a comprehension. So yeah, that's really, really nice. And then actually I do have two bonus questions.
Awesome.
One is, how do you declare a const unordered set? Kind of.
Do you use frozen sets?
Yeah.
Because a frozen set is an immutable thing.
At least the interface doesn't, there's no the common modification interfaces methods for you to modify the set. Yeah.
Okay.
How do you declare a read-only map in Python?
Read-only map.
Dict. Const unordered dict.
I don't know this one.
Yeah, there's this thing called a mapping proxy type. It's basically the same as a view into the dict, but you won't be able to change it. It's const. But it's up to date, always kept up to date. Yeah, actually once at work I encountered this. In one of my merge requests, somebody left a review saying is there a way to make the dict const? And I was like, there's no way to do it, man. It's not a set. I can't just do frozen set. And that's what I replied in the comment. And then we both Googled a bunch and we couldn't find it. But then I guess half a year later or 4 months later, I started studying Python seriously, and then I came across this. I was like, oh, whoops, could have used this. But yeah.
Yeah. Okay.
Next question. Do you know how to control memory allocation of your object in Python? This is actually a common question as well. For example, in C++, right?
Yeah.
You can say, you can do placement new, you can just use new, you can just allocate it automatically on the stack. In Python, when you do init, by the time when you do init, the object is already allocated for you.
Yeah, so
not sure if this is already allocated.
Yeah.
Rather.
Not sure if there is something that you can do with done new.
Yeah, that's exactly what you use. Yeah. That's also how you can use the singleton patterns in Python. Yes. Yeah, one way to do at least. Yeah, awesome. That's really good. I'm really impressed. If there's anything, I think one tip I have, the most important tip I have for you personally is that if there was anything that you felt like you had a hard time answering, feel free to draw parallelism from C++, because if you can show that you understand one language really well, people know that you have you have what it takes to actually dig into the internals of language and to really understand your tools.
Yeah.
And you'll be surprised, most of the time you say something in C++, that even the interviewer doesn't know C++, they will hear what you say and they'll be, oh, that's actually pretty close to what Python does.
Yeah.
For example, the list thing, right? Yeah, if you just talk about what you knew about vector, I don't know about Python list implementation really well, but I know in C++ vector, blah, blah, blah. And it might be very similar. And then I think any reasonable interviewer would take your answer as satisfactory. I like how you definitely know a lot about the internals of Python. There were some cases where you kind of missed some of the really basic questions in the first layer, which is really interesting. I think those things the SAP and the SAP operator is, or the exception when you iterate at the end of iterable. Those actually come up for sure from everyday use of Python. So that definitely at first painted relatively negative light when you're knowledge on Python, but quickly you were able to answer a lot of really advanced questions and show your breadth of knowledge in Python.
There's some interesting things that I tried with decorators as well. So I think a really nice decorator that you can write is a Memoize decorator, right? So if you know about memoization, it basically stores the function results. So the next time you make the same function call, it's just going to retrieve it from the cache. So that was nice to implement, and you can just write your own Memoize decorator and then use it. I tried a few other things as well. Recently, I tried writing another decorator, which is like a partial, essentially. Like if you have a function with, let's say, 5 arguments, you can bind 3 of them to a certain value and it'll return a function which now just takes 2 parameters.
Yeah, kind of like functional programming.
Yeah.
Python is not a functional programming language, but it has so much inspiration.
Yeah.
Oh, and the memoization decorator. I used it once in the interview.
Right, yeah.
Because I finished it so quickly, like the interview was like, what the heck? So yeah, it's pretty fun.
Oh, I really found this to be a lot of fun, actually. And I really like how you did you started at the iceberg. By the way, it's also very important because I know that a lot of candidates maybe know about GIL or AsyncIO, but you could mess up very simple thing. Like it's like, talk about immutability, right? As a concept. You usually think that, okay, a tuple is always going to be immutable. We can have a list which is mutable, still modify the list.
You can break the language contracts as well. There's a quote actually. A framework library protects against it protects against Michelangelo's, but it does not protect against the Machiavelli. It basically just means a tool, a library, like it protects against people who actually respect the boundaries. But it won't protect against people who are really like viciously trying to break the tool. And of course, like acceptance security is like concerned, right? For example, do you think the order of the items in a set is deterministic?
I'm not quite sure.
It's not, right? It can't. Otherwise, like it's a security risk. Attackers can just like craft something that they only need to do O1 work, but it ends up being O1 at your end because you have to iterate through the table. They can just like input 1,000 items, and then like each time you have to iterate to the end, for example. So for that reason, in Python, the set has a sorted hash up front. That's something random. Yeah, it's like a security thing. So yeah. But like for users' own like classes and stuff, like obviously don't have to worry about. This is like protecting against the user themselves, kind of. Yeah. Because the users know what they're doing. They just trust it. Yeah.
Yeah. This is really helpful. Thanks for sharing this. What was the time frame that you gave yourself from the time you started prepping for interviews to the time you said, I'm going to heavily interview now and going to land offers?
Oh, you should watch the first video I made. I talked about, I had a graph of my timeline. I see. That's cool. May I ask what you use to study for Python?
I've mainly used this blog called as like Real Python. Just some nice.
Yeah, I read that blog as well.
Yeah, it's a nice blog, and it's really like best practices that you could follow when writing code in production. All
right, we'll see how this video performs. If it's good, we can make another one.
I really enjoyed it, so I hope that we can do some other iteration of this in the future as well.
Yeah, maybe even for like C++, for like system design, stuff like that. But yeah. All right.
Thank you again for this.
Yeah, you do great. Thank you.
See you. Bye-bye.
Bye.